I've gotten a couple questions on this type of problem, so I wanted to make a quick video on it. I'm looking at the part 3 of Unit 1 inside our Khan Academy lessons. Any one of these are quite similar, but the particular question that I'm addressing right now comes from the second practice assignment, where we simplify rational expressions. On Khan Academy, the question looks something like this. Let me just resize the window here. We need to simplify the rational expression and then also identify which values of k make the expression undefined. And I think that's the part that some of us were really getting hung up on. So I'm going to take a screenshot of this problem and I'll copy it to my notebook so that I can actually write on the screen. So here we go. All right, so as far as simplifying the rational expression goes, I think, again, most of us are fairly comfortable with that by now. We essentially need to factor the numerator and factor the denominator. I'm just going to skip this space because I don't have enough room to write it, so I'll just jot it down over here. Now, the first thing I notice is that there's a common factor in the numerator of 5, and so I'm going to pull that out, and I'll be left with 5k squared minus 10k plus 9. And in the denominator, we don't have that, so I'm just going to copy that expression again. A lot of times students feel like this is a tedious step, copying work from one line to another, or from, one expression to another. But I don't mind it personally because it gives my brain a chance to relax when I'm copying so much information from the step before. I can think about the next step. All right, so now in this next step, that 5 that's on the outside in the numerator, nothing's going to happen there. So let's focus on this term here, or this group. Well, it's a trinomial, appears to be a standard trinomial, so I'm going to guess that k and k will work here. And since this is standard, I'm going to look for two numbers that multiply to make 9 that add or subtract to equal -10. And 1 and 9, of course, would work if the 1 is negative and the 9 is negative. So I think that's factored. In the denominator, again, we're looking at a standard trinomial. This one happens to be a perfectly square trinomial because this guy has a square root at the end, and the 2 times that square root would give us the 18 in the middle. Just turns out we need a -9 and a -9 in order to make that middle term negative. So with the factoring complete, we want to jump immediately to canceling out common factors, and we'll be left with 5 times k minus 1 over k minus 9. And many of you will say, well, the excluded value here is that k cannot be equal to 9, and that's because of this factor that's left over. But let's keep in mind, and let's stress the importance here, that even before we canceled these factors, there was an additional factor in the denominator here. Now, this particular example was unfortunately a bad one to choose because both of these factors are the same, but the point I want to make here is that even before the factors are canceled, you do need to check all of these denominator factors for exclusions. And so if this had been something else, if this had been something else, we would also want to include it in our excluded values. As it turns out, 9 was the excluded value in both of our factored denominators components, so we're just going to say that 9 is the excluded value on Khan's website. So I paused the video to enter that here. 5 times k minus 1 over k minus 9, I believe, is the factored result. And the one excluded value that we saw in the factored form of the denominator a step prior was just the number 9. 9 was repeated twice, so we'll only record it the one time. And if we check the answer, it looks like we got credit. Let me just see what the next one looks like to make sure that what I said a minute ago holds true here as well. I'm going to copy this on another page and then work through it and let you follow along. Okay, so here's that problem copied. The first thing that I'm going to do is factor the numerator and the denominator. And one of the tricks that you may have picked up or you may remember from a prior class is that in order to switch a binomial like this that has a subtraction in between, let's factor out a negative number. Sometimes a -1 is all that's needed, but in this case 3 is common as well. So by factoring out a -3, that's going to leave me with x squared minus 27. Oh, sorry, not 27, but minus 9, because we did divide out of 3. And again, this changes the order of that binomial. Instead of a number minus some x squared, we now have the x squared minus a number. In the denominator, it looks like 7 is our common factor, and so we're left with, well, shoot, another x squared minus 9. So, well, this actually isn't a bad thing, because I was a little disappointed that this is going to cancel out completely, and when we simplify, we'll be left with negative 3/7. I think that's a good simplified answer, but again, our excluded values come from here. They come from this factored form, and we're not even fully factored yet. So let's just jump down here. I don't really care what's in the numerator. That has no effect on excluded values. But in the denominator, if I were to continue to factor, I'd have an x plus 3 and an x minus 3. And again, the zeros of this denominator are going to be x equals negative 3 and x equals positive 3. Those are the two numbers that are excluded from the domain of this function. If you don't remember how I get those, just set each of these factors equal to 0. X plus 3 equals 0. X minus 3 equals 0. And after you isolate the x value, that should tell you what your excluded values are. That would even work if we had something more complicated here, like 2x plus 3 or 7x minus 3. Again, set each of those equal to 0. And then in this case, subtracting 3 from both sides and then dividing by 2 would give us the isolated x value. Adding 3 to both sides and then dividing by 7 would give us the isolated x value there as well. So that wasn't given to us in that form here, so I'd better erase that before I share something with you that'll be incorrect on the other screen. But again, excluded values here, positive 3, negative 3, simplified result, negative 3 over 7. So there's negative 3 over 7, and I'm going to say that an undefined result would occur when x is 3 or negative 3. And that works just as well. So again, I hope this helps. If you have any further questions, please let me know, and I'll record a video for you. Thanks.